Today we are going to discuss the exercise set 3.1 that is basically from the calculus by the SM Yusuf. That book is used for the BSc students and we are going to solve its exercise. From question number 1 to 6, discuss the validity of Rolle's theorem. Find C wherever possible such that f dash of C is equals to 0. In these questions, we have to satisfy the possibilities or the postulates of the Rolle's theorem, and then we have to find out the value of C. Before solving these questions, we must know that what actually Rolle's theorem means and what are the main postulates that we have to satisfy in these questions. Rolle's theorem is basically let f be a function that satisfies the following hypothesis. F is continuous on the closed interval ab. For example, we have a function. This is a function curve like f of x. Here on x-axis, this point is a and this one is b. This value is basically f of b and this value is f of a. F is continuous on the closed interval AB. It means that f must not have any undefined value between these 2 points of the interval and also including these points of the interval. F is continuous on the closed interval AB. There is no discontinuity or undefined term when we use all the values of this interval in this function f of x. If this postulate is satisfied, then we will move on to the second postulate. That is, f is differentiable on the open interval AB. For satisfaction of this postulate, we need to find the derivative of the function. And then we have to observe its behavior, that whether this function is continuous or not on this open interval. If this derivative function is continuous, then we will say that f is differentiable on this open interval. And then we will move on to the third postulate, that is f of a equals to f of b. We will use these interval values and put it into the function and we will see its behavior, whether it is equal or not. If both are equal, then we will find the value of c. Just put the value of c in the derivative and make it equals to 0. After putting it and making it equals to 0, find the value of c from here. So coming back to the questions of exercise set 3.1, discuss the validity of Rolle's theorem. We have to satisfy all the postulates of the Rolle's theorem for this question. And if all the postulates are satisfied, then we will find the value of c. So starting from the first question, f of x equals x squared minus 3x plus 2 on this closed interval a, 1 and 2. This 1 is a and this 2 is our b. This is a polynomial function. Polynomial function is always continuous on every real number. So we'll directly say like f of x is continuous on this closed interval AB, that is 1, 2. This one is our first postulate. Now we have to calculate its derivative. So for the second one, calculate f dash of x. F dash of x equals, we will use the power rule here, so it will become 2x, then minus 3. The derivative of x is equals to 1, so it will becomes minus 3. Plus 2, so derivative of a constant function is 0, so it will remain plus 0. So we will get the derivative value equals to 2x minus 3. Now we have to check whether it is differentiable on this open interval 1, 2 or not. I told you that again this is a polynomial function, so there will be no discontinuity. So we'll say like f of x is differentiable on this open interval 1, 2. Now calculate the value for f of a and f of b. F of a basically equals to f of 1. So it will be equals to, we will put 1 in place of x. So 1 square minus 3 into 1 plus 2. So we will get here 0. Again we will put f of b, that is f of 2. Put 2 in place of x in this function. 2 square minus 3 into 2 plus 2. Again we'll get 0. Now you see f of 1 is equals to f of 2 equals to 0. Since both the function values are equals to 0, so it means the Rolle's postulates are satisfied. The first postulate, f of x is continuous. The second postulate, f of x is differentiable. And the third postulate was f of a equals to f of b. Now we can find out the value of c. For finding the value of c, you have to take the value of f dash of x and put c in place of x here. So consider this f dash of x, that is 2x minus 3. Put c in place of x. We'll get 2c minus 3. And then make it equals to 0. That f dash of c equals to 0. So it means this term is equals to 0. So 2c minus 3 equals to 0. Calculate the value of c by using the basic algebraic method, that is your 2c equals to 0 plus 3. So 2c equals to 3. So c equals to 3 over 2. Now the last thing you have to check, that this c must be in this open interval. If it is in this open interval, then this will be our value of c. But if it is not including in this open interval, then we will have no value of c. So you see that this, for this number line, like we have 1 here, 0, 2, 3 and up to so on. This 3 by 2 is actually your value 1.5. So this will be between this. Here it is. So you see this 1.5 belongs to this interval 1, 2. So your c is basically belonging to this open interval 1, 2. So your Rolle's theorem is valid and your c value is exactly equals to 3 over 2. Now move on to the second question. Question number 2. That is f of x equals sine square x. And the interval for this is given 0 to pi. For finding a solution, first of all, you must know that this is a trigonometric function, sine curve, and you know very well that this is continuous between this interval. Sine has no undefined value between this interval. So it means f of x is continuous on 0 to pi. For the differentiability, you have to first find out the derivative, f dash of x, that is equals to, you will first use the power rule. Basically this is equals to sine of x whole square. So use the power rule, 2 into sine of x, 2 minus 1, and then take the derivative of without power, sine x. So you will have here 2 sine x and cos of x. That is basically the formula of sine 2x. So it's okay if you will stop here. Now you have to check its validity in this open interval 0 to pi. Again, sine is continuous in this interval, cos is also continuous in this interval, so you have no discontinuity between this interval. So f of x is differentiable in this open interval 0 to pi. Now calculate the value for f of 0 and then for f of pi. Use this function f of x, put the 0 here, then we'll get f of 0, that is our f of a, and then we'll put in the function x equals to pi, and that will be our f of b. We'll put 0 here, it will become sine square 0, so this will be equals to 0. Then if we'll put sine square pi, this will be equals to sine of pi whole square, so 0 whole square, this will again equals to 0. So our Rolle's theorem is valid because f of 0 is equals to f of pi. Now we have to calculate the value for c. So you have to do what? You have to take this derivative value. Take this derivative value. F dash of x is equals to sine 2x. Put x equals to 0. So f dash of c equals to sine 2c and make it equals to 0. This is equals, you have to take like 2c equals to sine inverse of 0. So you'll get 2c equals to 0 and pi, because if you can directly calculate it using your calculator, but also you know very well that sine is 0 on 0 and pi. Now c will be equals to 0 over 2 and pi over 2. So you will get here equals to 0 and pi by 2. Now you have to check that which c value basically belongs to the open interval 0 to pi. You have the open interval 0 to pi. You have to check which value belongs to this one. Now you see 0 does not belongs to 0 to pi because this is an open interval. This 0 is not included. So it means this is not your c value. So you will discard this c value and consider this one and check it. This pi by 2 is between this 0 to pi. So it means your c is pi by 2 because it belongs to your this open interval 0 to pi. Now move on to the question number 3. That is question number 3 is f of x equals 1 minus x raised to power 3 by 4, and you have to check it on interval minus 1 to 1. Now you see, if you use any of the value x value from here, you will not get any discontinuity or undefined value on this function f of x. Again, it is a polynomial function. So your f of x is continuous on this closed interval minus 1 to 1. Now take the derivative f dash of x. The constant derivative is 0. Then power rule, power down and power minus 1. You will get here 0 minus 3 by 4 x raised to power minus 1 by 4. That is equals to minus 3 over 4 x raised to power 1 by 4. Now you got some fraction. Whenever you will get some fraction, then you will check its denominator, because you know very well that fraction has some limitation, that if denominator becomes equals to 0, it means your function becomes undefined, your fraction becomes undefined. So you see, in this denominator you have x here. If your this denominator becomes equals to 0, so it means you will get an undefined value. So just check on which value this x is becoming 0. So you will get x raised to power 1 by 4 equals to 0 over 4. So x basically equals to 0. On x equals to 0, you will get a discontinuity. Your function will become undefined. Now check your interval. You have your interval. Your interval is between these values. Now you check whether this x is lying in this interval. You see you are having 0 in this interval. It means your derivative becomes discontinuous on this x value. So you will say f of x is not differentiable. Your f of x is not differentiable at x equals to 0. That is belonging to your open interval minus 1 to 1. So you will stop here and you will say that as one of the conditions of Rolle's theorem is not satisfied, so Rolle's theorem is not valid.